Good morning, everyone. I have the honor to present to you our research entitled Innovative Power Outage Detection Model for Electric Power Monitoring System. I am Leoderic P. Serami, the author, affiliated at King's College of the Philippines Bambang Campus with the position Dean, College of Information and Computing Sciences, with my co-author, Madam Telma Palawag, affiliated at University of Cordilleras, Baguio City, with her position, Graduate School Head, College of Information Technology and Computer Science. Lot of technologies are being used nowadays in different areas of power monitoring, especially in power outage detection. These technologies include the Internet of Things or IoT and Artificial Intelligence or AI. However, many electric cooperatives and providers in remote regions could not apply appropriate power outage detection systems due to insufficient knowledge of communication technologies. Moreover, power outage can affect homes, businesses, or entire cities that lead to loss of revenues, decrease employee productivity, and damage to equipment. The main objective of this study is to propose a power outage detection model or PODM that could be used to detect a power outage location. The researchers use a systematic literature review to gather the needed data to design and develop the proposed PODM. Cloud computing and long-range radio frequency were used for the proposed PODM. Mesh network topology was also used for the physical layout of the sensor nodes. The results of this study provide administrators and leaders of the electric cooperative viable technological or alternative solution for power outage detection. Furthermore, it will provide additional information for decision making. This study concludes that a combination of different communication technologies enhances electric cooperatives and electric providers in detecting power outages for stakeholders. Here is the introduction of our research. What is Power Monitoring System or PMS? PMS is an electricity network that enables devices to communicate to customers and suppliers, enabling them to manage demand, protect the distribution network, save energy, and reduce cost. Additionally, the system consists of a smart sensing unit that detects and controls the home electrical appliances used for daily activities. What are the roles of the Internet of Things in PMS? IoT, or Internet of Things, is a distributed data value creation scheme. It allows the sharing of data and coordination of choices by heterogeneous physical objects. IoT can be described as connecting everyday objects like smartphones, Internet TVs, sensors, and actuators to the World Wide Web, where the devices are intelligently linked together, enabling new forms of communication between things and people and between things themselves. Additionally, IoT is an application that reduces the implementation cost of every power monitoring application. Research motivations. However, despite the implementation of the Smart PMS program in a variety of applications, there is still lack of studies for power outage detection systems. Many electrical cooperatives and providers, especially in third world countries such as the Philippines, have still not been able to implement a fully fledged smart power outage detection system due to communication technology issues such as internet connection, which are widely installed in rural areas but limited to remote areas. The Philippines is a candidate for a power outage or the fall in a voltage in an electrical power supply scheme, whether it is planned or not. According to Senator Gatchalian, indicated that an hour-long power outage affecting the entire Philippines would cost roughly 4.49 billion pesos to the service and industrial sectors. Philippine Statistic Authority or the PSA also stated that a 1-hour power outage affecting NCR or the National Capital Region and the remainder of Luzon would cost the service sector and the industrial sector around 3.29 billion pesos, or 1.63 billion for NCR and 1.66 billion for the remainder of Luzon. Electric cooperatives are using different modes of communication tools during a power interruption and emergency. These technologies are the most commonly used tools by electric cooperatives and providers that cause inaccurate information and delays for power restoration. The general and specific objectives of the study. The main objective of the researchers to conduct this study is to propose a power outage detection model, or PODM, for low cost and could use both internet and radio frequency to detect power outage locations suited for remote areas. Specifically, the researchers would like to determine the commonly used communication technologies in PMS, their limitations, and issues so that an accurate PODM could be created. Here is our methodologies. The systematic literature review was used by researchers in this study to gather topics and knowledge to support this study. Cloud computing and long-range radio frequency were proposed for the implementation of the proposed PODM. Mesh network topology was also used for the physical layout of the sensor nodes. Mesh is a type of network layout wherein all nodes will cooperate to distribute data among each other. The findings and discussion of our study. These are the commonly used communication technologies in PMS. As we can see on this table, the technology used, it is categorized based on technology, spectrum, data rate or its bandwidth, and the coverage range. The first technology that we use is the GSM, or the Global Mobile Communication System, and the GPRS, or the General Packet Radio Services. Its spectrum is ranging up to 900 to 1,800 MHz, and its data rate or data transfer is up to 14.4 kilobyte per second, and its coverage range is start from 1 to 10 kilometer. The second technology is the WiMAX. WiMAX stands for Worldwide Microwave Access Interoperability or ACCESS, and is a point-to-point wireless networking technology. WiMAX technology is a wireless broadband communication technology based on the conventional IEEE 802.16 that provides high-speed information across a broad region. Its spectrum is from 2.5 GHz, 3.5 GHz, and up to 5.8 GHz. Its data transfer is up to 75 megabit per second. And its coverage range or coverage area is from 10 to 50 kilometer line of sight or 1 to 5 kilometer and long. Number 3 is the PLC or the power line communication, which is a communication technology that allows information to be transmitted over current energy wires. Its spectrum is from 1 to 30 MHz, and with the data transfer or data rate up to 2 to 3 megabit per second. Its coverage range is from 1 to 3 km. Number 4 is the ZigBee technology. It is designed to meet the distinctive requirements of low-cost, low-power wireless IoT networks as an open worldwide standard. The conventional ZigBee works on a physical radio specification of IEEE 802.15.4 and works in unlicensed bands. ZigBee communication is a communication technology for connecting local wireless nodes and providing high stability and transfer rate owing to low-powered data communication. Its spectrum is from 2.4 GHz up to 868 to 915 MHz. Its data rate or data transfer is to 250 kb. On this slide, I'm going to discuss to you the issues and limitations of the communication technologies that we have used. As you can see on this table, which is categorized into 3, the technology limitations and operation issues. The number 1 is the GSM and GPRS. Its limitation, low data rates, and its operational issues, costly operational infrastructure, only available on areas with cell site coverage. Number 2, the WiMAX, not widespread, and lack of quality due to heavy traffic, expensive network due to its operational cost, bad weather can interrupt signal, and power consuming and data rate. Number 3 is the PLC, harsh, noisy, channel environment, with operational issues, minimum security level, data attenuation, and high cost for residential appliances. And number 4 is the ZigBee, low data rate and short range, operational issues, low efficiency, and inefficient resource utilization. On this slide, I'm going to discuss the characteristics of suitable communication technologies for PMS. Number 1 is the scalability. This is an attribute that describes the ability of a process, network, software, or organization to grow and manage increased demand. Applications tend to be adequate. They must be scalable for future applications. Number 2, the interoperability. Different devices developed by different manufacturers may communicate with given communication technology as a result of PMS standardization efforts. Therefore, PMS must be built with interoperability as a key requirement, because interoperability in communication networks requires a wide range of communication technologies to work together so that utilities can select different technologies and providers suitable for their operations. Number 3, manageability refers to the collective set of properties of an entity. Example, a device or a network that allows it to be managed. These properties can largely be attributed to the management instrumentation of the entity, the management interfaces that it displays, and the capabilities that these interfaces provide. A variety of communication technologies are included in various parts of the PMS. Advanced head-end and network management software is a must for management as the communication system is built on several communication technologies. Number 4. Cybersecurity. This is the act of protecting files and directories in a network of computer against misuse, hacking, and unauthorized access to the system. PMS transition faces cybersecurity challenges. Although PMS allows sophisticated viewing and analysis of power grid operations through sensors, communications, and data analytics, cybersecurity risks arise. During PMS deployments, millions of devices are mounted on poles, wires, and sides of homes across the city, state, or world, and all of the devices in place need to communicate with utility computer system. These are the components of the proposed PODM. 1 is the sensor, 2 is the gateway, 3 is the cloud-based power monitoring system, and 4 is the monitoring. The sensor nodes. Long-Range Wide Area Network, or the LoRaWAN, is to be adopted in the implementation of the sensor nodes through Arduino and long-range technologies. Mesh topology. This network is a versatile node cluster network where new nodes can join the group and each node can operate as an independent router. The self-healing characteristic of the network enables communication signals to discover a different route through the active nodes if any node is to fall off the network. LoRa radio frequency. This technology is a long-range, low-power, low bitrate, wireless telecommunication scheme promoted as an Internet of Things infrastructure solution. The gateway. The Zigbee gateway model is also to be used in the proposed PODM. A gateway is a hardware interface between two networks. It could act as a router and firewall that enables traffic to flow into and out of the network. In this proposed PODM, it utilizes Raspberry Pi as its gateway. This is very important so that the smart system for outage detection could communicate to the cloud-based application PMS through its created IP address. PMS application. In this proposed PODM, it could utilize cloud computing or CC that acts as the main server of the system. CCs are information technologies resources via pay-as-you-go internet cloud services platform. The application of the proposed PODM could utilize two services of the cloud, the software as a service or SaaS and infrastructure as a service or IaaS. The proposed PODM could only deploy to the private cloud since the personnel of the electric cooperative could only utilize and manipulate the cloud-based PMS. The application could detect power outages once the LoRa RF has stopped sending a signal to the PMS. Technical supports of the electric providers or electric cooperatives could be notified of the exact location of the power outage through SMS. The cloud will also serve as the repository of security for the PMS. A backup system will also be installed in the institution's server or computer unit so that electrical cooperative can still detect power outages when there is a technical difficulty of internet connection. Remote monitoring. This serves as the user or operator computers. This is where the data being processed by the cloud-based PMS and the backup system is to be seen by the user or operator through website. The operator will then inform the technical support that could address the current power outage situation. In conclusion to our research, there is no single solution that can address the needs of all PMS applications, especially in power outage detection. Electric providers and electric cooperatives therefore select and combine different communication technologies to help all aspects of the PMS and allows them to perform different functions properly. This model has been created for power outage detection. This model could benefit the electric providers and electric cooperatives for easy detection of power outage, especially those remote areas with limited internet and cell site coverage. Thank you.